So just as a reminder, where we left off is last time we did a bunch of, I think, good refactoring of, we basically adopted this model of this WIT file being like our version of gRPC, or really this WebAssembly's ecosystems version of gRPC. And so it just defines these interfaces and defines some basic types and lets us define kind of records and enumerations and basic types like that. But that we wanted to keep this like kind of communication protocol, or wire format you'd call it, separate from our business logic. And so versus in our very first version, we were like moving fast and we just like use the WIT types everywhere. Now we have this really strong separation where we have this model file here that has essentially our business model. And so we have just, in this case, we're working in Rust. So we have Rust data types for everything we're doing of bidder IDs and item IDs and items and bidders and all these different things. And then we're using some of the functionality in Rust in particular to pretty easily implement these functionalities to just kind of go back and forth between our domain model types and then these WIT, or again, WIT gRPC-like types that I've just here through my imports, I've just prefixed all of those with WIT bidder ID or WIT bidder. And then that let us take all of our business logic and extract it into this file here called auction logic. And now I think this is like a lot more straightforward and a lot more readable, and I mean, almost boringly simple, right? Of like, we want to register a bidder. Well, what do? We create a new bidder ID. We put the bidder ID in the collection we have of all the bidder IDs. And then we just return it back. And it's like very, very simple here. And all this stuff, even this state, this is just another Rust struct. It's basically a bunch of hash maps. So essentially now this auction logic and this model file don't involve any code that isn't just Rust code in this case, but one I don't want you to like think is Rust specific. Like it's just the code for whatever language we choose to work in. So in this case, we're doing Rust, but I think actually once we get to a little bit of a breaking point on this, I think I'll do another Zymposium where we'll just do the same application, but we'll do it in another language. Maybe we'll do it in like Python. And well, fortunately, we'll be like faster because we'll have like learned a bunch of lessons from things we've done, and we'll actually be able to reuse all of the WIT code. But we'll just see how we get to the same thing in any other language. So it's Rust just because Rust is the language we're choosing to use today, but not because it has to be Rust. So we've got our domain logic here, we've got our domain model here, we've got our business logic here. And then this is really now a very small file, right? It's only 70 lines of code and spaces and comments and stuff. And essentially there's almost no logic here of, we're just defining this global state that just contains our business logic state. And then we're just implementing each of those parts of the WIT interface. And we're essentially just delegating all of those implementations to our business logic. And then we're just using these little helpers like into to change things back and forth between the WIT types and the business logic types. And having done that work in the domain model to implement those from and into traits, this ends up being pretty easy. You can just basically just slap an into on anything and go from the WIT type to the business logic type, or the business logic to the WIT type. So that's kind of where we left off. And so I think now the application just like looks much nicer and more maintainable. But the next step is, we talked about, we wanted to actually separate out the state more so that this application would be more scalable. Because right now, if we look at our state here, it's essentially everything that's going on in our auction system, right? So it's everyone who's registered to bid in any auction. It's every item that's available for auction, and then it's who's the winning bidder for every item that's on auction. And so what we're implicitly doing right now is we have one auction worker that anytime someone's doing something, they're communicating with that auction worker. And if we want to do like a small example, like we want to just get this going and, I want to list a little item and, Scott can bid on it. And then Terry can see if he can outbid Scott, like that'll be fine. But the reason that we build distributed applications is because we want to be able to scale to much, much larger volumes than that. And so far, this isn't like the most scalable architecture I think we could say, which is fine, right? We get started somewhere and then we kind of build on top of it. But what we'd like to do is we'd like to split this out. And what I think we started to sketch out last time is this idea that instead of just having this one auction worker with this kind of state that contains everything, we could think of maybe we have two types of auction workers. And so one of them we could call the auction registry. And broadly, that's going to be responsible for if I want to essentially create a new auction or get the auctions that exist. So that's a little bit like you could think of like the homepage of like eBay or something of you're going to start there of you want to create a new auction, you're going to send it there. And then we're going to have the second type of auction or a second type of worker, I should say, that we'll just call maybe the auction worker. Maybe this is the auction registry worker, and this will be the auction worker. And this so far, we can imagine maybe we're going to have one of these, right? You're always going to communicate with this first if you need to create a new auction. And we're going to say the volume of new auction creations versus auction interactions is going to be much lower. So we're going to be okay with only having one worker to do that. We could further expand this to make that an N workers and be even more scalable, but we're going to kind of take a couple of orders of magnitude first. And then we're going to have this auction worker, and there are going to be N of them. So this one, there's going to be one registry, but this, we're going to have one auction worker for each auction. And it handles all interactions with that auction. So that way, most of the time, you're dealing with a particular auction, everything you need is just with this worker. And any individual auction is going to have dramatically less activity than the aggregate of all auctions. So this is going to be much more scalable for us. So that's what we want to move to. Let me just quickly check in on the Discord and just see if anyone has any questions on that, or if you want to, feel free to raise your hand or unmute yourself. Dive into actually doing that. Okay. All right. So it seems like we're good so far. So my first step in actually doing this, I think, is I'm going to go to the WIP file. Naveel's not excited to do the next step. Yeah. That's exactly why we're doing this. And I think as we get into it, we'll also see kind of how to do it today, but also how, being very frank, like how to do it today is not as easy as it should be. And I'll kind of give you a preview of what I think it should look like and where we're getting to, but that feature is not available today. Okay, so let's go back to our WIT file here. This is kind of our specification, and I'm going to take a little bit of a specification first approach here. And so if we look at our existing set of methods and we think about kind of what should be where, so it seems like this register bidder, that really is, that's the auction registry functionality. And maybe the fact that we even need this is saying there's some further like authentication functionality, either in Golem or other worker we're missing. But I think right now we'll say this is going to be part of the auction registry. And similarly, this function of kind of listing all the items also seems like part of the auction registry functionality. And we could imagine eventually we can put some kind of caching in front of this so that if we have lots of users who just want to see like what are the items available, we can just cache that. And if we give them a 2-second out of date version, it doesn't really matter. So these are both going to be auction functionality. And this is also going to be part of the auction registry. But then these functions to bid and close on an auction is going to be part of the individual auction functionality. And so I think the first thing I'm actually going to do here, just before we dive into splitting these out, is I'm going to do a little bit of minor refactoring just to change some of these method names to be a little bit more reflective of what I think we're going to do as we split it out. And so I think I'm going to change register bidder to be create bidder. And I think I'm going to, maybe this is really more like create auction, because this has information about like the limit price and the expiration. That's really more than just the item here. So, and this is also going to maybe make us a little bit more CRUD-like, you could say, right? So we're going to create, and then maybe this is like get auctions, and then maybe these we can leave as is. And maybe I'm going to change this from being an item to an auction, and this from being an item ID to being an auction ID. Just, I think that'll make things a little bit more sensible as we then kind of go from this world. So I'm sure I've broken things here. So I'm going to do metal cargo component check. And I'm just going to, yep. And where it's, oh, yep. So this is going to return an auction ID. And I'm just going to do this once before I start splitting this out, just to get myself ready here. And then just give me a list of auctions. And should probably just take all of these. Okay, and then just blown up stuff here. So let's do the same thing here. So I think basically anytime I've got an item ID, I'm going to make that an auction ID. And anytime I've got an item, let's see, maybe this just, I want to keep the capitalization correctly. I'm sure there's fancy things I could be doing in VS Code, but let me just, so this will be create bidder. We said this was create auction. This is let's get auctions. And then every time we've got a WIT item, it's a WIT auction. And then let me go to my model here, and I'm going to do the same thing. So every time I've got a WIT item ID, that'll be a WIT auction ID. Every time I've got an item ID, auction ID. And then I just gotta follow through some of these compilation errors. Model here. Okay, perfect. So I'll just run cargo component check. Make sure all it's working. Okay, perfect. So now I've basically got same program. I've just cleaned up my names a little bit. And I just want to do that because what I'm basically going to do now, and I'm just going to check in on the Discord one more time and make sure. Okay, perfect. What I'm basically going to do now is I'm going to split this up into 2 different WIP files. I'm actually going to split essentially into 2 different sub projects here. And so I just want to kind of get that refactoring done now, so I don't have to kind of end up doing that twice. And here we're going to get to like a little bit of like an architecture choice of ultimately what we're going to want here is essentially, you can almost think of these, we're going to have 2 different types of workers. To use an analogy, you could think of this as like having 2 different microservices almost. And so it's kind of the classic, like, do you have a monolith or do you have more of a modular structure here, where what we're ultimately going to want is we're going to want to have 2 different interfaces. And so one will be the auction registry interface, and we'll implement that. And one will be the auction worker interface, and we'll implement that, and then we'll hook them up. And so if we wanted to, we could just have, even in the same file, we could have different interfaces and we could pull those in. But I think what I'm going to do is have a little bit more of a modular approach, where not this auction application is that large to really need it, but we can imagine if we were doing a bigger thing, that these would really kind of be different services almost, and maybe there are different teams that are responsible for the auction registry versus the individual auctions, and optimize them and making them great. So what I'm going to do is I'm going to create 2 sub projects in Rust, one for each of these, and I'm going to let them essentially be their own separate worlds, and they're really just going to communicate with each other through this interface. So it's going to be like a maximum degree of modularity, and in fact we could like write one in one language and one in a completely different language, and that would be fine. So to do that, I'm going to just start by creating some folders. So I think I'm just going to call these kind of auction and auction registry. We could pick different names, but I think that's what I'm going to go with, unless anyone objects. And then I'm going to take all of my existing code, other than my like very top level things like my git ignore file, and I'm going to pull all of that stuff down into, essentially I'm going to kind of pull it into both places, and I'm just going to delete the stuff that doesn't make sense in each one. So maybe I'll do the auction registry first. So I'm going to pull everything in my source folder here into the auction registry. I think I'll just get rid of this now because I don't need it. I'm going to pull the WIT file into the auction registry. And then I'm going to pull this cargo file into here. And then I'm just going to get rid of these because I'm just going to blow this away right now. So now I've got essentially all my logic in this auction registry. And then I'm going to create a new cargo file here. And this part is just like the way you do this stuff in Rust. And I'm just going to make these 2 things of the auction and the auction registry a part of it. And then let's see. Fail to be. Oh, I need to. What's that here? Oh, I think I need All right, so let me just take this out for a sec because I haven't done the auction one for a sec. Now, think. Okay. So it's just recreating the stuff at the top level because I've done the structure. Maybe if I hadn't deleted that, it wouldn't have to create that, but that's okay. Okay, so you can see we're compiling again. We got the sub-project here, and I'll add some nonsense here just to make sure that yes, we really are compiling. That really is working great. And then what I can do is I can actually create a second one of these. So I'm going to take all of this code here. And right now I'm just going to copy it and I'm going to dump it in here. And then I'm going to go here. And now I should be able to add in auction as well. Let's see if I can, so I just need to update my cargo file here. And I need to update the name of this project and call it auction registry. There we go. Okay. And let's just double check as well that this is actually compiling. So I'll do some nonsense here. Yes. Okay. So now I've essentially got two sub projects, and the way Rust does this is relatively nice, where as long as I'm in this like parent directory here and I just do cargo component check, or I do build, it's going to take both of these things and it's going to build them together. So that's great. And so now I'm going to start going through each of these and updating them to be just the logic for their component. But first, I'm just going to check with questions. Yeah, so this wit file, so the way that this actually gets kind of brought into our language, whether it's Rust or anything else, is with this. Is by using this bindgen thing here. So yeah, you don't have to, there are kind of different ways you can lay out your file and different kind of approaches to that. I'm kind of, again, going for the more modular approach, but there are different approaches to kind of how we could organize this. So we could also just have multiple wit files just in the same wit folder in the same project. Or we could even have more stuff in like the same wit file. But right, so you see here, like this export API is where I'm exporting this API here. And if I wanted to, I could have multiple interfaces and I could export more than one interface. So I'm just kind of doing what I think is setting us up for like, again, the most kind of encapsulation between these. But there's no reason you have to do that. And you could definitely do the opposite approach and say like, hey, this is a small project. I want to just like have everything together. Okay, so let's keep pushing forward here. So let's maybe do the auction registry first. And I'm going to basically do a little bit of approach of like renaming and deletion, you could call it. So I'm going to rename this to be auction registry instead of auction. And I'm just going to get rid of the parts of the interface that aren't relevant here, right? So I think these three are the ones we said we wanted to be part of the auction registry. So we'll just leave these. And then let's look for a sec at these different data types and see if they're still relevant. The bidder ID, we definitely still need. The auction ID, we still need. The bid result isn't really relevant to us here because that's more of a concern of an individual auction. It looks like the auction we're still using. Looks like all the other types we're still using. And the idea here is kind of this auction ID is going to be the key to one of the individual auction workers. So we'll be able to use the auction ID to look up the auction worker that's associated with it. Okay, so now I think we've got our interface here looking decent. Now I've probably created a ton of compilation errors here because I obviously just like blew away a bunch of stuff. And we can see that indeed we do. So I'm gonna just basically make similar changes here of we clearly don't need the bid result. And we can furthermore say we just don't need this bid or close auction functionality. And we don't need that as part of our model either. And then this whole bid result thing I can blow away. This is another example of that choice between modularity and kind of integration here. Of we could also have one separate shared dependency that had our domain model, which might reduce our code overlap a little bit, but also means that if one of these modules wants to change its domain model, then it has to carry over to the other one. I think I'm going to here go for like the maximum modularity initially and have these each have their own separate models. So they could even potentially be refactored as separate languages independent of each other. But that's another thing that is totally your choice. There's nothing about using Golem that requires that. That's just kind of the way I'm happening to do it today. So similarly here, I'm going to clean up my logic from the auction logic, which maybe I should rename auction registry logic at this point. I don't think I'm using time either, so I think I can get rid of this. Let's see, or maybe I am. Oh, I am because I'm okay, so I'll leave that. Okay, so let's see. I think I'm actually compiling here. I'm going to do, I think I can, maybe I'll just rename this to auction registry logic for consistency. See if the rest of one wasn't quite. Maybe I just needed to save. See if yep. Okay, perfect. Go Rust editor. Awesome. Okay. So now I think the final thing, or maybe one or two things more I can do here, is I can go to my state and I can say I don't need all of my state here anymore, right? I don't need these concepts of who the winning bidders are, because that's a concept that is specific to an individual auction. So I'm just going to blow that away. And I'm still compiling here. So now I basically got my logic for my auction registry, right? I have a smaller piece of state that's basically now just like keeping track of who's a registered bidder in my overall auction system, right? Who's a registered bidder at the auction house, and what are all the auctions that are going on at the auction house. And I just have basically a pointer to all those different auctions, and those all be their own workers. And so I can create a bidder and create an auction, and I can get the auctions. And that's basically the only functionality that I need here. Just going to check in on the chat for a second. And see Phil is writing something. So I'm going to give Phil a minute here. And anyone else who wants to jump in, please feel free to do so. Yeah. I think there's eventually some cleanup that we could do here. But I think we'll kind of get the basic architecture working, and then we can do that. Okay, so let's then go over to the auction. And so for the individual auction, we're going to basically follow a similar approach. And so I'm going to start with the WIT file, and I'm just kind of going to do the opposite of. I'm going to say these three are not relevant. I definitely want the ability to bid. I want the ability to close an auction. Now, one thing that's worth noting here is at this point, we don't really need this auction ID parameter anymore. because we already know if we're a particular auction, if you're calling us, just by the fact that you're calling us, you're telling us which auction ID you're interested in. So we can actually remove that from our signatures here. The other thing that we're going to need to think about adding is a way to do some initialization, because we now want this individual auction to know essentially the things we were putting inside as part of our shared state before. We wanted to know what its ID is, what its name is, what its description is, all this information, both because we're going to need to use some of it as part of our logic, as well as eventually, if we want someone to be able to just access this auction and we want to like render a web page based on that, we're going to need some of this metadata, like what the name is and description. So there are a couple of alternatives for what I described as the equivalent of constructor arguments in Golem. So maybe I'll just make a brief little note here for us. And I'd say there are basically three ways. So one is that Golem lets you specify environment variables to a worker when you create it. So this can be useful for like passing configuration information or really any information you want to. Maybe this could also be useful for like some type of context, right? You want to know like the context of who was calling this or what path this came through. So one way we could pass this information into this worker is through environment variables. Second way that's similar to that is Golem also lets you specify command line arguments to a worker when you create it. So again, very, very similar. That's another way to pass information into your application. One disadvantage of both of those is that they're not strongly typed, right? If you pass in command line arguments, just like in any other system, they're strings, and you have environment variables, they're maps from string to string. So those can both be good solutions, but that is kind of a downside to both of them. The third alternative is you can specify your own initialization function. And you might remember if anyone looked at like the shopping cart example we have, that was a pattern that was used there. So there was like a initialized shopping cart method where you specified a user ID and that basically initialized the state of the shopping cart with that user. I think that's the approach I'm going to use right now. I will highlight this is an area where we're actually looking at making some improvements to the API here, because what we'll see is when you use the initialize function, you kind of have a two-step process of like, we create the worker and then we'll call the initialize method to initialize it, which is okay, but it would be nicer if that all got taken care of in like one step. So we're working on some stuff where you could do more of like, if you're coming from a object-oriented programming background, you would do like new auction, right? And you just have 4 different parameters that you provided to it. So I think that's something that is coming, but again, does not exist today. So I always kind of like to give you both, here's where we are today, as well as where we're going, because I don't want to make you think, oh, like this is not great, and we're like not thinking about it at all. Yeah, so here I'm going to create a function, and I'll call it initialize. And this will be a function. And I think I can take advantage of this auction type here, because this contains all the information I need. So basically, when this auction gets initialized, we'll give it all this information, and then it'll just store that away, and it'll maintain as part of its state that this is the name of this auction, this is the description, and so on. And eventually we could imagine maybe you start an auction and you want to change the description or what have you. We can have more functions to do that. but right now we'll stick with what we've got here. Okay, so I'll take this out for now. Just that doesn't really. All right, and so now when we go down here to our implementation, let's follow some of this through. So creating a bidder is obviously not part of our API anymore. Neither is creating an auction or getting these auctions. But we are going to need this function initialize. That's going to take one of these auctions. That's a WIT auction. And it's not going to return anything. And right now, I'm just going to make this to do. Initialize. And then I'm just going to keep following my compilation errors. Oh, and I'm not spelling things correctly. Initialize. Oops. Initialize. Okay. And then I need to update my parameters here because we said I didn't need the auction ID here because I already know that. So I'm going to update these parameters here to reflect that. And I think for now, I'm just going to comment these out and also make them to do just so I can get through the rest of my updates and then come back to them. Okay, so now I'm compiling again. And now I'm going to do a similar exercise. Well, first, let's go back to the WIT for a sec. Let's make sure everything's still relevant here. So at this point, I basically want to look at all my interfaces and see if I have any types that aren't used in my interfaces. So my bid result I'm using, my auction I'm using. I don't think I'm using this deadline type, so I can get rid of that. And I'm using this auction ID type, and I'm using this bidder ID type. So I think I can just get rid of that. And oops, what did I? Let's see. Oh, maybe I am using. Where am I using deadline? Oh, it's part of the. Okay, so I can't get rid of that. Okay, sorry. Okay, so I think I'm good with my WIT file for now. So now we'll go to the rest of my logic here. And so I can do a similar thing where I can look at my state and I can say, boy, there's a bunch of parts of my state that I don't need here at this point. So really, what is my state at this point? Well, I don't need either of these. I probably do need this auction that's like essentially who am I? So right now I'm going to make this a option of an auction, which is a little bit of a work around the fact that I had that two-step initialization here. And the winning bid, I now don't need this map from auction IDs because this kind of implies I'm keeping track of all the option IDs. So I think this can also just become a option of essentially there may or may not be a winning bidder. And if there is a winning bidder, then they have a certain ID that identifies them and there's a winning bid price. And so with that now, I can make a bunch of other changes in here. So we're going to start out without that information. And then I'm basically going to go through and I'm going to update my auction logic here. And so one thing I can do is I can just blow away the methods that aren't relevant to this. And I really only need to support these two. And then this one doesn't need the auction ID because again, this is a specific auction. So we already know our auction ID. And then let's just follow this through. So before we were saying winning bid was winning bids.get. Well, now I think we only have one winning bid. Okay, I should just rename it. I was confusing myself here. So let's go down here. This really should be called winning bid because at this point, there's only one winning bid. Okay, so now this winning bid is an option, which is actually the same thing we had before. So then if there is no winning bid, then before we're going to insert it in the map, now we can just set it. So we could just say state.winning bid equals. So check if there's a winning bid. If there is no winning bid, set the winning bid and say, okay, you were successful in bidding. Otherwise, get the winning bid price. And if your price is higher than that, and I think we don't need to dereference that anymore, then same thing. And otherwise, so your bid was too low. And then if we want to close the auction, well, again, we don't need to get in the map, it's just an option. So if there's no winning bid, then there's no winning bidder. Otherwise, get the ID. And then I'm not quite sure why we were doing this remove logic here. I'm not sure that makes sense. There is some more logic we need to do here to really, we need to maintain some state of just whether the auction is like open or not. And we just set it to some final close status so you can't bid on it anymore. But I think I'm going to just try to like do this refactoring first before we come back to that. And now I think we just got some minor Rust things. So let me see. So I think I need to clone this here. Okay. So now I am compiling again here. I still got a couple of to-dos in my main module here where I've got to actually go back and I've got to use this stuff. So I think I can basically bring back what I had. And my methods have the same signature, except I didn't have, let's see, we're a state, got a bidder ID. Oh, right, and I just don't need this item ID or auction ID. And so similarly here, just don't need that. And I think I should be compiling here. Yep, I just have this to implement. And so I think this one can be pretty straightforward as well. Except maybe I should actually create another helper method here. So I could have something like public function initialize. And it's going to take a state and auction. And then it's just going to say state dot auction equals. Oh, so. Okay, and then I go back here and I can just do initialize and give it the auction, convert it from the width type, and this doesn't return anything. So I think I should get there. Okay, so I've basically gone now from having one monolith type service to having two individual services, one of which we're going to have many instances of, and the other of which we're going to have one. So we'll have one worker for the auction registry. We'll have potentially millions of workers for the individual auctions. And they now both basically have their correct internal logic. The final important step we need is we just need to wire up the communication between them. So I'm going to check in one more time, and then I'm going to get started on that. And I think probably given time, I probably won't. Well, we'll see if we get through it or not. But okay, so let's think about like what's wrong here. So I think the logic for the auction worker is basically totally fine. I'll just delete these things for cleanup, but that's neither here nor there. But where we're really missing, where we're really missing something is in the logic for the auction registry, and it's basically in this create auction function. Because what this function is doing right now is it says, hey, you want to create an auction with this stuff? Well, I'm basically putting it into my internal list of auctions, but I'm not actually creating a worker that's going to be responsible for that auction. So we need to add some logic here where we say, essentially, so this thing here is returning this WIT auction ID. So we could, let's maybe split this out a little bit more. So we could say something like here, oh, and I should probably rename this thing to, yeah, this should probably be create auction as well. I'm just going to go over here, create auction, let's say better, and yeah, auctions, just to keep things nice and tidy here. Okay, so this auction registry create auction, this returns an auction ID, right? So we could say, so far, we're just making this a little bit more modular, right? Just, oh, I'm missing a semicolon. Okay. So now what I want to do here is I basically, in between these two, I need to start the auction worker. And then the auction ID will correspond to the worker ID for the auction worker so that the caller can interact with the auction worker directly. So I think the first thing to do here is I'm going to slightly change the signature of this method and have it actually return. Well, we have a little bit of a choice here how much we want to, again, put into this versus push back into this create auction method. So I think maybe I'm going to stick with the idea of keeping all these methods super simple. I'm going to push all of this into my auction registry logic. So I'm just going to undo this here for a sec, just because we'll do it in the other place. So I'm going to go over here. And so just really, I guess, restating that here is where I need to now create the auction registry worker. And then the auction ID will be the key to the worker, so to speak. I'm just going to catch a couple of stray references to item versus auction. Okay, so this is where I'm going to go through the way to do it today, but I'm going to preface it with it should be way easier to do in the future. So if you think about going back to these WIT files as being like gRPC, right? The way you would typically interact with gRPC is you'd use a library. Like if we're in Scala, you use a library like ZOgRPC, or if you're in Rest, you use a library like Tonic. And basically what that library would do is you would just say, well, hey, just given that you've got a auction worker defined in this directory, and you do some statement to kind of say like, hey, the worker's this directory, it would auto-generate for you a client, basically, that would have a typed interface where you would be able to say, if this auction registry had like an initialize, you could just do like auction registry dot initialize, and it would have all those types, and essentially all the communication under the hood is covered for you. I think that's the state that we want to get to. That's not the state that exists today. The state that exists today is you can use the REST API, which I think it'll be a good thing for us to look at, just because ultimately, if you're interacting with Golem, like everything ultimately goes through that API. So even if you're not doing like, this is worker to worker communication, so we should have this more efficient protocol for you. But for whatever reason, maybe in some cases you need to use the REST API. So it's good to see that. But definitely, I think it should be more straightforward in the future. So what I'm going to do here is, I guess one thing I always think about whenever I have kind of logic is going to take some work is I just start by extracting it somewhere else. So I think I'm going to create a new file here, and I'm just going to call this, say, auction. And so this is basically within this repo here, this is going to encompass all the logic for communicating with an individual auction. And I can, let me just add that to my modules here. Okay, so let's start sketching this out. So we're going to need some function that creates the auction worker. And that's going to take this auction that we've defined before. Just going to bring in my whole data model. And I don't think this is going to need to return anything. So right now I'm just going to make this node to do. And then we're also going to have one to initialize the auction worker. And I think this one will probably actually only need the auction ID to initiate with. So be a little bit more specific there. And then I can bring that into here. And so we can say, really, all we need to do is we need to do auction create worker, and maybe I'll say create auction worker just because it's kind of implied here. Oh, and this, maybe I'll just be simpler here. So we're going to do auction create, and that's going to need our auction ID. And then we'll do auction initialize, and that we're going to need the whole auction data type because we want to give it all those parameters. And then I think we're just going to need to do some imports here. And then I think we've got maybe a little bit of Rust, just memory safety stuff. Let's see. That I should spell correctly. All right, and yeah, so let's look at our errors here. Just got to, yep, so the auction, so we can just on this guy, and this guy. Okay, great. So now this logic looks correct. So we just need to actually implement these methods here. And so this is where I'm going to encourage us to hop over to the Golem Learn Center, which has some great information. I'm just going to grab some stuff from the REST API. So give me 1 sec while I just grab that. And you can, I'll post this link after we're done as well. So this is just the golem.cloud.learn. And there's a nice section for the REST API. And I'm just going to basically grab the ones that we want. And so if you scroll down, actually, let me share my screen with you for a sec, just so you see this. All right, can folks see this okay? So we want to create a new instance. So I'm going to scroll down to the instances and create a new instance using the latest version. That sounds good to me. So I am going to grab this just so I have it. I'm going to paste it in. I can only kind of show you one thing at a time. So I'm going to just grab the other one I need. So that's to initialize, that's to create a new worker. And then I want to call a function on a worker, and I want to wait for its result. And so I'm going to grab this one here. And then there's one more that we'll need, which is you'll notice that this API here, to invoke a worker, if we want to wait for its result, it also requires this thing called an invocation key. And the reason the invocation key exists is basically to let our applications be resilient in the presence of failure when we want to wait for the result. So if we don't want to wait for the result, if we just want to kind of fire something off, then we can just fire something off. But the idea is, let's say that I invoke a function and then I'm waiting for its result. And while I'm waiting for its result, I fall over. So if we don't have anything else, we have a little bit of a problem of we don't really know whether we fell over before we made that function call and the recipient never got it and never started working on it, or whether they got it, they started working on it, and we just fell over while we were waiting for them to get back to us. So the invocation key basically solves that problem for us by giving us a reference to that function invocation, which is why it's called an invocation key. And so the idea is that if we fall over, then all we have to do is we just call the same function again with the same invocation key, and Golem has the logic to know if it's already seen that invocation key, it won't compute the function again. It'll just find the function that's already running, and it'll tell you about its result when it has a result from that. And if it hasn't seen that invocation key, then it'll start the function from the beginning and run that. So we're also just going to grab this one to get an invocation key here. All right, and let me do a new screen share here so we can go back to the code. Okay, so I've copied these 3 just API samples, so I have them. And so just for our recollection, this one is create a new instance. This one is get an invocation key. And this one is invoke a function and wait for its result. So the first thing I'm going to do here then is I'm going to do just one more level of pushing these to smaller functions. So we can have some non-public functions. So we can say, maybe this will just be called create instance. And then get the invocation key. And this is going to return us a string. We could have that be more strongly typed, but right now it'll just be a string. And then we're going to have this, I'll call it initialize instance. And then, so this one is going to need to know the auction ID. This one is going to need to know the instance, is going to be the auction ID as well. And then this one is going to need to know all the information about the auction. So let me just make sure this is compiling. Great. And so now I think I can implement these two in terms of my initial one. And maybe I'll actually wrap everything up in this create. Maybe we might say like, hey, this creation initialization thing is kind of a detail that like shouldn't be exposed at this level. So maybe we should just have one function create. Maybe that's a nicer way to do this. So then here, we could basically say, okay, so I need to create my instance. Oh, and then this will need to take the whole auction instead of the auction ID. So I'm going to call create instance with the auctions ID. Then I'm going to get an invocation key. With the auction ID. And then I'm going to initialize the instance with the auction ID. And then I think the only thing I need to do is, again, I just need to clone this since I'm reusing it here and here. Actually, I can probably, okay, and then let's, right, and then here, this needs to be the whole auction instead of just the auction. Okay, great. So now I need to implement, oh, and then this one, initializing it is going to also need the invocation key. So here, this is take the invocation key. All right. So now I need to do the actual HTTP calls here. And for that, I'm going to need a library to help me with doing HTTP. So at least in Rust, the go-to library is one called request with a W. And if you go to the Golem Cloud open source repo, we actually have our own fork of that just to make sure it works with the right versions of all these different WASI components. So I'm going to bring that in. And let me go to my cargo file. And we'll see how much. So I do want request. This is fine. Now, because it's our fork, I need to specify a repo for it. And so let me go and find that one. Give me 1 second here. Right now, so it's this one here. And then we're working on improving this. But right now, there's also a particular branch we want to target that I believe, yep, is called initial WASI impl. Let me cargo check to make sure that we're actually bringing that in. Oh, and I think I just did cargo check instead of cargo component check. So, okay, all right. So it found that, it pulled that in, so that's great. And so here's where we just got to do like a little bit of the boilerplatey stuff. So let's see if I can remember the right incantations here. So I think I want to create a new client. And then I do want to create a URL. That's not the right URL, but that's fine as a starting point. So my URL is, so the base here I want is release.api.golem.cloud. And then we'll just kind of do, let's say the first one here. So it's components, and then the first one, and then instances, instance name equals, and then we'll have a second one. We're not going to use environment, command line arguments or environment variables right now. So that should be fine. And so this component ID is one that I would have had from when I created the component. So right now I'm just going to give myself a little bit of a placeholder here of, let's just say we're going to call this component auction. And then let's say instance ID is itself going to be a lot of the times there's nothing you have to do, but a lot of times we've used this component of the instance ID as like the instance, and at least if it doesn't have any special significance, just a number basically. Or here we could use we're using this UUID from the auction ID, so that's totally fine. So it'll just be auction, and then it'll just have this UUID. And so then we just need two, so we'll just say, oops, component ID, instance ID. And then I can just post that. I don't need to await that here. I think it should work. Let's see. Just get this. I'll just and we could do some error handling here too, and some of that will happen for us automatically. Okay. So I think we basically got what we need here. The only thing we are going to need to do is also, if we go back to the Learn Center, let me just grab this because I forgot to grab it before. There's this note here. So I'm going to need to add a header to this. And again, I'm going to not actually, we could load my, we could load the authorization token from like environment variable. I think that would probably be a good use for something like that. But right now I'm not gonna do that right now. So right now I'm just gonna say token is token. Let's hit there, not that. And we're just gonna do similar things for these other ones here, just with their slightly different APIs. So the invocation key is going to be looking for components instance ID. So let me just try to get this right. So components, and then this next one is going to be instances, and then key. These two should be fine. So that should be fine now, except we're going to need that. And then I think we can use the text method on here. Semicolon there. Let's see. Yep. And I have a reasonable degree of confidence. I'm sure I made some silly mistake in doing this, so we can afterwards make sure this all gets working. But I just kind of want to get all this at least down here. And then the initialize instance is the one where we're going to need slightly more work. Because if we look at this one, so we're going to do components, component ID, instances, instance name. So this first part is great. And then we're going to call invoke and await with the invocation key. And then this thing, well, first, we're not going to need this text stuff because we don't need something back from this. Let's see. This will be auction.auction ID. Okay. And then the final thing we need here is we need to actually provide it with these, with the parameters here for this function call. And so if we look at this, it says request body consists of the invoked parameters, JSON, looks like this. So let's try to do that. So I'm going to try to take advantage of some of the functionality that I've got here. So I believe I can do dot JSON. And I can do my auction. And that's going to require I have the JSON feature enabled, which I think I do. I do. And then I'm going to need a way to convert that to JSON. So first, okay, what's a reference instead of a value? Fine. And then, yeah, so it needs a way to serialize this. So I am going to bring in another dependency here for serialization. This is kind of the conventional library to do it in Rust. And then I believe there's another feature for UUIDs to support serializing them. Let me make sure that all my components are working here. Okay. And so it's, okay, I don't need that. And so now I'm just going to go to my data model. And I'm going to go to my auction. And I should be able to drive serialize. And I'll just need to import that. So that's use serialize. And then, so basically for this to be serializable, all the parts of it have to be serializable. Like if you're coming from Scala and you've done code derivation there, you've probably seen that. So I'm just going to go to this auction ID. We should be able to serialize this. And then I'm going to go, I think deadline's my only other one. It's not a standard type. So should be able to serialize this. And okay. So now, again, this is the type of thing where you should definitely do some testing because it's very easy to make silly mistakes here. And I would probably bet that I've done one somewhere. But at this point, we're using the REST API to communicate with our workers here. And so we're now, again, kind of abstracting from exactly the HTTP calls we're making there. What we're doing here is when someone says they want to create a new auction, we are creating a new ID for it. We're keeping track of that in our own list. So if someone wants to see all the auctions, they can get it. And then we're actually spinning up this auction worker and we're handing them back the ID of that worker so then they can call that worker and they can interact with that auction directly. So this should make our application dramatically more scalable than our original kind of hello world one. Okay, so I think we're over on time, and that's me talking a lot. So I'm going to check in on the Discord here, answer any questions, and then I think we're going to call it a day here. Okay, so Phil, you are super active, which is awesome. So a question: create a worker, no handle for initialization, and turn it into a. You're right. So like I said, I think we're going to have a different way. Kind of in the future to do a worker or to interact with one. So I think currently you're kind of seeing it, which is once you create a worker, you can just call methods on it with its worker ID. So the worker ID is essentially the handle for the worker. But I think what would be much nicer for all of this is if this all got replaced with something that essentially this is complete pseudocode, but use whatever auction width, auction dot width for auction, and then you got to do something like auction new auction, right? I think that's the like ultimate experience that we want to have. Now that's going to require some support in different languages. So I think one thing you're going to see more of in that Golem Cloud repository is more open source repos to do stuff like this. I mean, this is essentially what, like, again, in Scala, like Zio gRPC would do, or in like Rust, what a library like Tonic would do, or pick your pick your language and your library. But it would be really nice to kind of not have to deal with this ourselves, though the reality is we probably have to deal with lots of APIs and kind of work with their REST APIs. But I think this would be super nice. And so I think you'll see more stuff like this in that Golem Cloud open source flow. And that's also something, if you have interest or ability to contribute to, there are lots of languages and we'd love to have amazing support for all of them, but that's probably more than just we as a team can do. So I think the community getting involved there to the extent you have interest, that would be fantastic. And then there was also a question of the creator is responsible for choosing a fresh ID. Yeah, so the ID is completely arbitrary. I mean, here we use UUIDs, but it could be incrementing numbers, or it can also be just human readable strings, right? It could be Adam's auction worker or John's auction worker. If you create something that's a duplicate of an existing one, you'll get an error there. And I guess if you were worried about that, you could have some logic of, well, if I do, then retry. But yeah, it's completely arbitrary, and you get to kind of use the one that you want to. And then, no, so Phil, that's actually wrong about the atomicity, because you're not giving anyone a reference to this worker until you've created it. So you're completely fine from that perspective of initializing it, though I definitely agree that it would be cleaner there. And then yes, I'll definitely push the code up. And again, like I have a feeling I've made a silly mistake somewhere here. And I mean, clearly some of the things I'll just like put in like token for the token, which needs to be an actual token. But yeah, I think with kind of some minor changes like that, this will be ready to go. And I hope this was helpful for everyone. Yeah, so I think yeah, we're almost at the hour and a half mark. So I usually try to keep these at an hour, definitely not today. But I hope this was helpful for everyone. I think this is now like way closer to being an example of kind of what a little bit closer to like a real Golem application would be, where we have different workers and they're communicating with each other. And obviously it could be much more complex. You have completely arbitrary patterns of communication between these different workers. It doesn't have to be just like one way, or this kind of like master and, that's probably the wrong word, but supervisor, and then creating these individual workers. It can be any pattern you want to. But hopefully this was helpful, and really thank you everyone for taking the time. It's great to get to share this with you, and I think it's great for me to get your feedback and also to just kind of work through this. And I think you can see as we go, we see things that aren't working as well as they could be, and or just aren't as easy to explain as they should be, and we feed all that back and try to improve that, just like we did with the data model and kind of WIT. And I think we've got a better model for that now. So thank you again, and have a great weekend. All right.